Hello all. Turn down. See? She knows. She knows. As soon as I start talking, she knows. Puck is often very good. He's just been a bit food aggressive, but I'm sure you can hear Tinker. Yeah. Yeah. Well, if you get on camera, you get bits. Come on, go. Get over there. Yeah, Puck's been a bit food aggressive, so we'll keep him out while we're waiting for everybody to kind of pile in. Just kind of make it bigger so everybody can see the dogs. And then I'll put them in the crate and they'll get a special treat. So, yeah. She's been feeling timid because he's been kind of mean to her. Like, I'm throwing Cheerios and she's looking at me, watching me throw Cheerios, but she won't go over there. And usually he is a very good boy, and it makes me sad that he's acting up like this. So, yeah, there's that. I guess they act like there's a food scarcity or something, but there's never a food scarcity. Yeah, I'm talking about you, dog. I keep throwing Cheerios and she's like, I don't know about this. I don't know about this, Mom. Hey, thanks for the bits, Veronica. So I got the Cheerios. Puck. See, he's too busy to hunt to say anything. Puck, can you speak? Nope. Tinker's like, I want those Cheerios though. And make it rain! Let's see if we can rotate the camera. Nope, she's still off screen. Up there she is. There's her head. So, but yeah, thank you, Veronica, for the bits. See if I can get my thing to clip where I want it to clip. And apparently I have not muted my phone, which might cause problems. Alright. Yeah, Puck is a very anxious dog. And so is Tinker. They both have their issues, and when I got them, I was very anxious, so that may have rubbed off on them. Puck's a little more solid than Tinker is, but yeah. They're both really good dogs. They're just not like dog park dogs. Yeah, you're a very happy boy. Can you sit? Can you speak? Please? Please? Puck, speak. Come on. Okay, that was a start. There you go. Speak. Come on. Come on. Speak. Louder. Louder. Alright. Can you speak? Come on. Speak. Yeah, he's like, just throw the treats already, Mom. Oh, so how is everybody's day going so far? It has been a quiet yet busy morning for me. Favorite human mowed the lawn bright and early before he went to work. So yeah, that's pretty awesome. My lawn is mowed. I won't have, a lost dachshund in the grass. Yeah, I know. I keep pelting Cheerios over there and Tinker keeps not eating them. So in a few minutes we'll put Puck in his crate. But it looks like it will be a nice day, and I may or may not leave the house after this. some of my library books on space toilets are due on the 11th. So I'm either need to go to campus today, or I will probably just send an email and have them renewed. Because I got through the congressional report, but I'm not done reading the space toilet one. What? Can I help you? She's like, no, you cannot help me, Mom. You can never help me. What a world. Annie looks like Kimberly, and Kimberly looks like Scully, and I am afraid to look in a mirror. Oh, okay then. I don't know what Kimberly you're referring to. Paranor says space toilets, yes. Hey Susie, hey Larry, welcome. Yeah, space toilets. Alright, so do I have the special treats around? I do. So I bought these super awesome treats when I was in Edwardsville. Dr. Kimberly Cartier. Okay. You know what? I probably met her. I probably have met her. And I can see where you draw the resemblance. Tinkerpuck. I did not... See, here's the thing. I did not go to Astronomy Cast 500. I met her at AAS, I think, or AGU. I think it was AAS. Yeah, I was at the Hangout-a-thon. I did not go to... I probably could have gone to AC 500, but I don't know why I didn't. I honestly don't remember why I didn't go. Yeah, I did the Hangout-a-thon. But I think I met her in DC. So that had to have been AGU. Because I remember playing around with a table that taught you how to, or demonstrated erosion. And, I remember her, she was there, and the other person that shows up frequently on Weekly Space Hangout were there. And then we, went to food with them later. So, there was that. So, aw, thank you. Alright, Puck, can you get in the crate? Come on, Fluffy. Get in the crate. Go on, get in there. Look, there's the treat. Here's the other. Come on, get in there. He's like, but if I go in the crate, I miss out on the treats. Alright, so I'm gonna wrangle the dogs the best I can. The treat's in the crate. Aw. Oof, get in there. Alright, there you go. See? You found the treats. Alright, lock him in there, and now we should be able to see more of Tinkerbell. Cranium open now. Yeah, pretty much. Pretty much. Okay, so let's get us some Tinkerbell on camera. So here's the treats. See what a difference it makes when Puck's not around to bully her. She's like right there, which is kind of funny because she's the older dog. And she is definitely the, when she was younger, she used to be the alpha, but I think it's just because he's bigger than her. Get over there. Alright, so I feel like we're still waiting for people. So, we'll do our usual thing and wait. Like, I don't know where Guido is. Where's Guido? I see a lot of our usual suspects, but I don't see Guido. Oh, there's Guido. He's just being quiet. So, we can't ask Guido. Oh, he fell into the soup pot. Did I miss it? Oh, space toilets, I arrived at the right moment. Okay, there we go. I got distracted by putting Puck into the crate. Alright, he fell into the soup pot. I wonder what's for dinner. Now I'm hungry. I think Puck's still looking for the treats in his crate. Okay, so now that I think everybody's here, I'm going to turn off the music. And oh shoot, I just realized that I don't have quite everything set up the way I should have it set up. I know, Tinkerbell. I know. You're forever sad and forever sad. So I have 2 stories for you today. Oh, potato salad again. I have 2 stories for you today, and then we're going to play with the Moon Mappers tool together. So I was not expecting to be doing Daily Space today, which is why we only have 2 stories. And yeah, so hi. Hi, I'm Annie. I am not Dr. Pamela. I am going to attempt to cover space science today, which is a bit harder for me than rockets. Hey Refs Matt, welcome. So this is Daily Space. I feel like I should run the thing real quick. I probably should run the thing real quick to make the official marker of when we start. So let's do that. And then we'll get on with the show. I know, Tinkerbell. I know. Alright. So here's the video. Hi, and welcome to Daily Space for today, May 9th, 2019. I am your host, Annie Wilson. I am not Dr. Pamela Gay. Dr. Pamela is at a convention in Budapest, and her schedule just doesn't allow for doing Daily Space today. So I have 2 stories for you today, and then we're gonna play with something cool. All right, so let's get started, shall we? So I apologize in advance for all the dog whining in the background. There's just not a lot I can do about it. All right, so the first story. Hey, really? As I was saying, let me get there, Tinkerbell. I'll explain what's on the screen in a second, Tinkerbell. I'll get there, Puck. Anyways, so before we get into our first news story, we're going to review some classification things that are related to stars. So what you're looking at right now is an HR diagram, and it's essentially, the simplest explanation is that it's a scatter plot of stars showing the relationship between brightness and color, which is also temperature. So, yeah, this is important. See if I can kind of show you with my cursor. So this right here is the main sequence. And that's pretty much how most stars live. They start one way or the other, and I'm not an astronomer. I can't remember how to explain this. Although, by looking at the... Shh. Tinkerbell, you're not helping. You're not helping me remember this. My Astronomy 101 class was a really long time ago, guys. But essentially up here you have your blue stars that are really bright. You kind of transition, these are like the really big blue stars. You transition into your more yellow and whitish and blue stars. And our sun is right here on the main sequence. And at some point, our sun will turn into, I can't remember if it's I think it'll be a red giant. So our sun will leave and turn into a red giant at some point. But there are some red stars that are, you know, kind of small, because they also try to represent, you know, size on here. So we're going to be talking about blue supergiants, and the best example of a blue supergiant is Rigel, which on the HR diagram is right up here. And another blue star that most people are familiar with is the brightest star in the nighttime sky, which is Sirius, which I think is actually a binary star, which is down here. So it's much smaller than Rigel, and it is actually brighter than Rigel. And I know that there are other things that show that they're brighter than Sirius, but Sirius is pretty much the brightest. And yes, blue is hot. Keep this up and you'll have like a front row seat in my lap as I talk about this. Oh, thank you for the bits, Ed. Somebody felt bad for you, Tinker. All right, so here's the Cheerios, and we'll do this again at the end. And make it rain. All right, thank you for the bits. Ah, there we go. Thank you for the correction, Wilburster, saying that Sirius is main sequence, which there it is, and Sirius B is the white dwarf. I know they're a binary system, and together they're pretty bright. So thank you for the correction. So yeah, we're going to be talking about blue supergiants. Rigel's the good example. Luminosities can be 10,000 to 1,000,000 times that of our own sun. Super freaking bright. They're fairly rare, and for a star have relatively short lives, but because they're so freaking bright, it's easy to spot them with the naked eye in the nighttime sky. So, for those of you unfamiliar with where Rigel is in the sky, Rigel is in the constellation of Orion. So here's Orion, and this is the orientation from, quite honestly, the northern hemisphere. I know it looks kind of upside down. And so here's Orion's belt, which is one of the easier things to pick out, depending on your light pollution, Orion's belt is pretty easy to pick out. So here's the armpit, Betelgeuse, which is red. Here's another armpit, here's a foot, and Rigel is one of those feet, and I have it circled in red. So Veronica says right foot. Thank you. Rigel is totally the right foot. So now that we're all caught up on what a blue giant is and where you can see one, now we can talk about the news story. So this is a pretty wild image, right? This is a snapshot from a hydrodynamical simulation of the interior of a star 3 times as heavy as our sun, which shows waves generated by turbulent core convection and propagating throughout the star's interior. Darker and lighter colors represent fluctuations due to waves. So that's very sciencey and very heavy, and I'm going to break this down for you. So a team led by Ven, I'm going to copy paste this into chat because I'm not sure of my pronunciation. I know it's an institution. Discovered that almost all blue supergiants shimmer in brightness because of waves on their surface. That kind of explains all of that. So blue supergiants, like Rigel, vary in brightness, or they can look like they're flickering, or even, wait for it, twinkle. So we've known that stars have twinkled for a really long time. We just didn't know why. We just knew they did. So it turns out that this twinkling effect is literally due to waves on the surface. Okay, how do waves get to the surface of a star? That was a really difficult question to answer, especially considering that it's very difficult to observe the interior of a star. We're really good at observing the exterior of a star. Think of when you observe the sun, which, yes, is safe if you use the correct equipment. When you observe the sun, you can see sunspots, you can see solar prominences, flares, if you will, things of that nature. You can see these on the sun. These are all surface effects that we can see on the sun. So, in theory, we could also see these kind of effects on, blue supergiants. Please don't quote me on this because I don't know if that's actually a thing. But, so yeah, these waves. These aren't like waves on an ocean where they just go across the surface. They're actually coming from the inside of the star, which is wild when you think about it. Trying to think of a good way to explain this. Like if you attached ribbons to a fan, because I think a lot of people have seen this, ribbons are things to a fan, and you can see the ribbons moving, even if the fan was behind something else that wouldn't let you see the ribbons moving. The ribbons aren't moving from nothing, they're being moved from the air from the fans. So that's the best thing I can think of. Sound waves might be a good thing. Magnetic fields is probably what generates these waves. I know, Tinker, it's confusing. It's pretty complex, but yeah, scientists, quite frankly, have figured out a way to observe these waves coming from the core of the planet and rippling out to the surface, which makes the surface shimmer, which is super cool. That is super cool. We know why, these stars twinkle. But there's also more to this. No. You picked a bad time to call. There's also more to this. There's the fact that from the frequencies of these waves, scientists can figure out the physics and the chemistry of the inside of the star. So things like what kind of metals are in there? How exactly, does all the stuff inside the star move? Neat things like that. Plus, we get a really, really cool picture, which actually has a lot of science behind it. And now I just kind of want to play with them. So, yeah. So that's news story number 1. And news story number 2 isn't quite so complicated. I don't think it requires as much explanation. So this is a picture of Haumea. Haumea? Haumea. We're going to stick with Haumea. Haumea. I am so sorry to everybody that knows how to pronounce Hawaiian, and I didn't write pronunciation notes in my notes. So this is actually one of the Pluto killers. Yeah! Okay, I know. A lot of you still like Pluto. So this is a dwarf planet located beyond Pluto in the Kuiper Belt. It has 2 moons, and it has a ring. So I think we've observed the moons directly. We have never directly observed the ring, and I'll get to that in a second. So, yes, this planet, this dwarf planet, is a funny shape. This image is not distorted. In fact, it's an artist's, rendition. It is a funny shape. It's more of an ellipsoid. I know! It's more of an ellipsoid than a sphere. So it's more like a rugby ball or an American football ball than, like, I don't know, a basketball, soccer ball, football to the rest of the world, or even a baseball. So yeah, it's not spherical, it's an ellipsoid. More of an egg shape? A really long egg shape. So, yes, it is a funny shape. The shape is thought to be caused by how quickly it rotates, which is 1 complete rotation every 4 hours. So, yeah, 1 Haumea a day is 4 Earth hours. Just 4 Earth hours. And as I said, I'm getting there. Wow, you're noisy today, Tinker. I'm getting there, Tinker. So yeah, as I said, it has a ring, and in this image you can see a ring. So I also mentioned that we haven't directly observed the ring. We're probably never going to directly observe the ring because of how far out it is, how small the ring is. It's a really narrow ring. But we know it's there. So there's this thing called occultation, where something passes in front of a bright object. So if I were to take... I don't know how well this is going to work. So if I were to take, I don't know, my eyeglass case and put it in front of one of my lights, you can see that the light changes, right? You may or may not be able to figure out exactly the shape of my eyeglass case, but you can tell that the light changes. And if that doesn't work, think of like shadow puppets. If you do a, shadow puppets, you have a bright light source, you do shadow puppet-y things, and then you look on projection surface and you can see whatever the hand shapes turn the shadow puppets into. Another example could be, I'm not sure how accurate this is checking eggs to see if they're fertilized or not. They take an egg, they plop it on a light, and based on how the light it goes through the eggshell is whether or not you can tell that there's a thing in it. So yeah, that's how they measured the shape and probably the size of Haumea as well as its ring. Essentially, they took detailed measurements of light fluctuations when Haumea and its ring passed in front of a star. That's kind of a complex thing that I hope I broke it down and helped you guys understand. So, but yeah, Haumea and its ring blocked light from the star, which is how they know for sure that there's a ring. And they took all of this data from recording the light fluctuations from when this event happened and plopped it into a computer and did some computational modeling, and they figured out that the ring of Haumea is not as ellipsoidal as the dwarf planet itself. It is actually kind of circular, which is a little weird. There's also some mention of how is this in a stable, orbit around it. It doesn't have to do with resonance. It has to do more with like periodical orbits and things. And there's so much that they have found out about this object through computational modeling that I couldn't even digest it all. But the biggest thing to me is that, yes, there's a ring. We know it's there. Yes, we know it's a narrow ring, and we know that it's circular, not ellipsoidal. So, yeah, that's a lot. And I wish I could explain everything that they did with the research with that better, but I just can't. So here, in lieu of being able to explain everything, there's the link to the press release, and I'm going to flip back to chat and DoggoCam while I check for your questions. And after I check for questions for this thing, then I'm going to set up to check out this new cool thing that I want you all to play with. So I'm going to scroll back up, and some of these will probably have already been answered by chat. So yeah, if there's more than one answer from both chat and myself, sorry, not sorry. Refsmat says, can we guess what Jeff Bezos is going to announce at 4 p.m.? Nope. So the HR diagram came from Wikipedia. It's also from ESO, but I found it on Wikipedia Commons. I don't think I kept the link for it in particular. Wikipedia actually has a lot of really good HR diagrams that you can pick and choose from. And blue does indeed mean hot. I know it seems a little counterintuitive for when we color things, when we learn to color things, we're taught to color things blue as in cold. So things like ice and freezing temperatures and things, we've all been conditioned that blue means cold. That's not the case when it comes to flame or light. Blue is hotter than red. So I really don't know how this kind of misinterpretation came up, but when it comes to flame, blue is hotter than red. Welder torches, as somebody mentioned, are pretty blue. Flame on a gas stove, it's pretty blue. Bunsen burner, the flame is pretty blue, and those are all really hot. So yes, blue is totally hotter than red, and all of that. So Ed did not get, you know, Tinkerbell eyes for his bits. Tinker. She's like, you just tossed bits, Mom. Alright, we'll let her eat those. Tinker. Are you ready? Oh, more bits! More bits, really? You want more? Alright, Tinker, can you get? Tinker. Alright, there. Now we have Tinkerbell eyes. So here's the Cheerios. And make it rain! Thank you for all the bits, Ed! Thank you for all the bits! Okay. So we covered the blue versus red, which, yeah, I know it's confusing. I know. I'm not looking forward to explaining this to my nephew or my niece. Yeah, that's another way to think of it is, so a rainbow is Roy G. Biv, right? So you have red, orange, yellow, green, blue, indigo, violet. So blue and indigo, or blue, indigo, violet are on this end, and red is on this end. And ultraviolet means above, you know, above blue, and we know that as, I think it's ionizing radiation. We know that as the stuff that's really bad for your skin, but also needed for, you know, plants. Actually, plants don't need UV. But yeah, we know that is the stuff that's really bad for your skin, and we need to protect it. So infrared, or below red, can also be interpreted as heat. So, you know, infrared cameras, when you're trying to find, you know, people in the dark, that's another way to do that, is with that. So I don't think infrared is ionizing. I might be wrong. I forget a lot of this. It's been a while, guys. But yeah, so infrared, which is something that we perceive as heat, but it is definitely lower on the electromagnetic spectrum than UV or ultraviolet. So if that helps you understand the colors, good. I hope it helps. If not, I'm sorry for confusing you further. So yeah, brown dwarves are weird. They're very cold. Paranor says, so they're using them like S&P waves. I don't know what S&P means, and Paranor is talking about the, see if I can pull it up. Paranor is talking about this image in particular. and the waves from the blue giant. I don't know what S&P means. So, dwarf planets. Yes, the Haumea definitely does indeed look like a rising loaf of bread. Or a dragon's egg. I like Ref's Matt's comment. It rotates in accordance with the tennis racket theorem. Fenring says, so it works only 1 hour a day? Seems good. Oh my goodness. I don't know. Dogs were really upset that I didn't know something, and I'm sorry for everybody's ears. I don't know if rotational velocity reduces the surface gravity. I don't know how much smaller it is than Earth. It does kind of look like a crushed moon. It does indeed. As John Terloon points out, rotational forces send you away from the center of rotation. That is the way the Earth bulges at the equator. So yeah, Earth isn't a perfect sphere. It's kind of squished a little because we spin. So yeah. Oh, stretch. The ring shape is based solely on the gravitational force. The rock shape is based on the rotational force and impacts that happen over the decades. There was stuff about the stability of the ring shape and a few other things, and it mentioned orbits, and I am so sorry, guys. That is above my level of understanding, and I quite frankly did not have enough time to digest it all. So, yeah. Yeah. Aha, there we go. Fenring did indeed point out ionizing radiation is the one that has sufficient energy to ionize atoms. It's UV and above plus alpha and beta particles, which is terrifying. Okay, so the blue being cold, according to Jean Verloon, is from the Greek-Roman color grading. Fire to them never got hot enough to turn blue, so fire was red-orange, and blue is cold as blue. Hey, I'm getting there! Due to ice caves being blue in general from the color of the sun through the thick ice. Which, if you've seen a glacier, this makes sense. I will eventually have to find all of my glacier pictures. Alright, bye Larry Weird and Proud! Okay, so that was all of the news. It looks like I caught up to everybody's questions, and now we're gonna do the thing, if I can, get my stuff together. So now we're going to do the thing that you've all kind of maybe not been waiting for. So, shh, it's okay. So we, and by we I mean it's not really we, CosmoQuest.org. So we have been working hard, which is, we is Pamela and Tanner, by the way, on getting the Moon Mappers project back up. Give me 1 second and I will flip over to the website. So here's the website as it looks today. And for the longest time we told you things aren't working, things are working. Guess what? Stuff is working. So Moon, we're going to click on Moon, and we can actually map the moon. So this is a brand new interface. It has a brand new tutorial. We are still, testing this, making sure it runs okay. I'm gonna let the other dog out because maybe that'll stop some of the whining. So this is still under testing. We're still trying to work some of the problems out. If you're on our Discord, let us know about any problems you run into in the channel Moon Mappers. That way we can keep track of all of the bugs you encounter. If you email them to us, they might get seen. I know they won't get seen by me. But I would put everything in our Moon Mappers channel of any bugs you find. So I know one of the bugs I'm running into already is that I can't log in, but I think that's a me problem and not so much a site problem. So we're going to run through the tutorial together. And this is a new interface. There's new graphics. And the first thing it asks you to do is to erase a mistake. It says, so first we accidentally made a mistake here and we need you to erase it. And click OK on the dialog box. Then it prompts you to click on the eraser tool to select it. And then it prompts you to click on the crater mark to delete it. Poof, it's gone. And then the next step is to circle some craters. And it tells you craters are circular holes in the ground with bright sunlight on one side and a dark shadow on the other. This is actually important. And then it'll show you some examples over here. And you just kind of click through and you can see how, like this one right here on the left is very well defined. The one in the center, not so much. Some of these are tricky to see. They really are. And then the tutorial is going to mark the first two. Anything smaller than your cursor is too small to be circled. And you can tell that when, like if it's red, it's too small. Just flat out too small. So if it's green, it's large enough. You just kind of want to get the edges. You don't want to make it huge. That's too big. Just get to the edges as best as you can. Not all craters are perfectly circular. And if you have an image with a lot of craters, a lot of decently sized craters, you can turn the marks on and off. If you don't want to look at the examples, you can turn the examples off. And then you click submit to submit the image. And then this is a... Really? I'm getting there. This is a lighter image. Some images of the moon are light, some are dark. So this is asking us to get as many craters as we can. It wants us to only get 10. Now it's definitely mentioning the if the crater's too small, it'll be red. Hey Puck, Tinker ran off, so you get all the bits. So here's the Cheerios. And speak. Come on, speak. All right, there's Puck. And here comes Tinker running in and make it rain. Also, now I'm wondering if the doggy door is still locked. So there's one crater. There's another crater. It wants us to get 10. Like this one's too small. Here's another crater that's kind of off the screen, and you can actually move the circles to get it. And this one's a bit tricky because it doesn't really have a really good defined crisp edge. So I'm going to turn off marks because that one mark is just getting in the way. Oops, that's not good. Shh, 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 shh. All right, so I've broken it already. See folks, Annie has already broken a thing. So apparently it's just better to get the smaller craters before going after the... What do you mean you don't think it's correct? It is totally correct. And some of these are really faded. And I think it's going to be a struggle for me to get through and get as many craters as it wants that I feel are crater worthy. And if you do this, don't worry too much about being perfect. You'll get better with time. I know when I've circled craters on stream in the past. Some of you have commented that I circle way more craters than, you know, others of you. What do you mean that one's a bit too small? That one is not too small. And yeah, you just kind of keep doing the tutorial, which I have at least 10 in there. I know I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12. Well, that's as far as apparently I can do, because I think I have enough. It apparently doesn't think I have enough. Okay, so I found a bug already. But yeah, if you can manage to go through the tutorial and get past this stage, please do so. I'm just annoyed at the tutorial right now. And Thompson says it's probably a layer 7 issue. I don't know. I don't know. But yeah, so the Moon Mappers is up. Please go test it out, do the tutorial. If you can get through the tutorial, please let me know. You can post in Discord. I'm going to post now that I couldn't get through the tutorial. Complete the tutorial. I circled at least 10. 10, the software didn't think so. Okay, boom. See? It's that easy to report a bug. And I think that's all I have for you guys. I have a very whiny puppy. She has been very vocal. So I'm going to get ready to roll the credits, which is always a little tad bit awkward. If anybody has suggestions of who to raid, now is the time. Now is also the time. This is your last chance to ask questions. I am going to do all of our station identification stuff, roll the credits, and then we're going to raid somebody. Oh, thank you for the bits, Bombadil. Puck, are you ready for more bits? Puck. Speak. Come on, speak. Come on. You can do better than that. Come on. Look, that's what I got. Here's the Cheerios. Speak. Come on. There he goes. Puck thanks you. I thank you. Here's the Cheerios and make it rain. Oh, whiny puppies. Whiny puppies. Thank you for your patience with the whiny puppies today, guys. I really do appreciate it. So, station identification stuff. This has been a production of CosmoQuest. We stream every Sunday through Friday at 1 p.m. Eastern. Right now that's 1700 hours UTC. Sundays is myself. Hi, Annie. Colorizing space telescope data. I am currently working on Spitzer. I think it's Spitzer data of 2 interacting galaxies. Monday through Fridays is this, Daily Space, where we bring you daily-ish astronomy and space news updates, which is super cool. And we are literally brought to you by you. So thank you for all of that. All of your bits, donations, subscriptions, merch purchases, Patreon pledges, all of it goes to essentially help pay for myself and Susie and Tanner do our things. So yes, thank you for all of your support. I really appreciate you guys, and I'm grateful for the fact that I am one of the lucky few part-time streamers that gets paid to do this. So yes, thank you so much. Plus, you know, when there's a follow and bits, see, like that, there's a follow and bits, there's almost always some, you know, fun things like Cheerios being thrown at dogs. Are you ready, Puck? Speak. Oh, see? Puck thanks you, I thank you, and make it rain! And that is one of the best ways I know how to thank you guys. That's immediate, and I hope amusing at least, and cute. Even if my dogs get a little icky and weird. So, our host institution is PSI, that's Planetary Science Institute in Tucson, Arizona, working in collaboration with Youngstown State University here in, yeah, I really do think it's spring, Youngstown, Ohio. PSI is a nonprofit 501c3 corporation thingy. Anyways, where laws allow, your donations to PSI are tax deductible, so that's cool. And yeah, we're on the social medias. The biggest place that I personally am active is on our Discord. We also have a Twitter and a Facebook page and a YouTube page. And subscribe to our YouTube channel. It's the one with all the videos, not the one video. Because that will help us get our videos higher up in the search results so people get real science instead of not real science. Plus, on our YouTube, after a day or so, you can go and watch all of our videos. We archive pretty much everything we can on the YouTube page. So yeah, that's one of the things that Susie takes care of, and Susie is awesome because of that. And I think that's everything. Oh yeah, that's right. I almost forgot. Follows. Follows are free. If you can't afford to, you know, actually subscribe, bits, whatever, that's totally okay. I really understand it. I love seeing, you know, new faces in chat. I love chatting with you guys. I love hanging out with you guys. So give us a follow, because we don't just stream on this schedule. We also stream things that we don't have scheduling power over, like rocket launches. Rocket launches are super cool, guys. And occasionally there will be other random streams, like me getting ready for the next day's daily space, me talking about whatever. So there's that. And yeah. Let's see, is there any housekeeping news? I think the only housekeeping news is that I think the people getting meteorites, your addresses have been passed on to Richard, who is going to mail out the meteorites. Most of everything's been boxed up at Pamela's and ready to go. Hi, Evolve! And, with the exception of Veronica Cure stuff, I hurt you because I still owe you things from the Hangout-a-thon, and I figured it was easier to just send everything together in one box. So when I do eventually make it to university, I am, you know, doing the thing. Oh, Pamela's streaming? Like right now? Really? Now I need to check, because if she's streaming, we'll raid her channel. Yeah, that's why you haven't gotten anything, is because I wanted to put everything together. So, yeah. Everyone else, I don't have control over your packages. Veronica, you are amazing. I have not forgotten about you. You will get your stuff as soon as I go to campus and get everything in one box. So, I don't see Star Strider active right now. So, oh, not right now. Okay. I think she's still doing things. I don't know what time it is in Budapest. Alexa, what time is it in Budapest?
In Budapest, it's 7:47 p.m.
Oh geez, she's probably still eating dinner or something. It's 7:47. So maybe later tonight she'll stream, maybe? I don't know. I promise nothing. Anyways, so I saw that somebody said that Rhyolite was streaming, and I'm not sure if we've rated them before. So I'm trusting you guys that he's family friendly, and I am going to get ready to awkwardly stream the credits, because that's how we do credits here. And I think that's everything I have for you guys. Thanks again so much for, you know, tuning in and hanging out, and your patience with, you know, the small amount of craziness that happens when Dr. Pamela's out of town, because I am not a clone of Dr. Pamela, and sometimes I am a very poor replacement. I wish I knew way more astronomy on the level that she does to explain some of the news bits that we covered today, but I hope I did a good enough job. So I will see you again tomorrow, and where I will hopefully have more space newsy things that I can help break down and digest. And if I can't find anything, I guess we'll talk robots or something. So until then, thank you all, and be kind to each other. And if the skies are actually clear, look up. Have a good day, evening, morning, night, afternoon, wherever you are in the world. And yeah. Thank you so much. I'll see you tomorrow. Bye.